Okay, in the previous video, we looked at the first step of free radical substitution of an alkane, which is initiation. Now we're going to look at the second step, propagation. Okay, because of the constraint of the video, I can only cover one step in each video. Okay, so what happens in the first step? Let's recap. In the initiation, we talk about radicals, free radicals forming, which are very reactive because they have one unpaired electron. So what does this free radical do? Okay, the product in the initiation, the free radical Cl dot that is formed in the first step, okay, in the initiation, will react with the alkane molecule, the ethane. Being very reactive, the free radical, it will force the alkane to react. So what happens in propagation is that propagation consists of two steps. Okay, so we can broadly classify them as bond breaking and bond forming. Okay, so what do we mean by this? If you look at the overall equation for the free radical substitution of ethane, okay, what is happening is that the CH bond is breaking. And what you are doing is you are basically forming a bond, the CCl bond. So in propagation, this is what happens. Okay, the chlorine radical is very reactive. It will force the CH bond to break. Okay, so if I represent this hydrogen electron as a cross and this carbon as a dot, okay, the bond breaks homolytically. Okay, and then what will happen is that this yellow color hydrogen with its cross, okay, here, will combine with this green color chlorine to form the HCl bond. So what is happening is that the H with its electron, the cross, will combine with the Cl unpaired electron to form the HCl bond here. And do you notice that there is this purple color dots on this carbon here? So this is what we call a free radical, an ethyl radical. Okay, so we get the ethyl radical. So in this first part of the propagation, the CH bond breaks. You see, if I want to substitute a hydrogen of an alkane with chlorine, I must first break the CH bond of ethane, and then I can form a CCl bond. Okay, so this is what happens. So in the first step, you must break the CH bond first. And in the second part of the propagation, the CCl bond forms. How does this occur? This ethyl radical that is formed in the first part of the propagation is again very reactive. Remember, radicals are extremely reactive because of the unpaired electron. So what happens is that this Cl bond, right, okay, will again break homolytically. So what happens is that this ethyl radical will react with a chlorine molecule such that, again, the Cl bond breaks homolytically. Okay, it breaks homolytically. So one electron of the Cl bond goes to this left-hand side chlorine, the other one goes to the other chlorine. So this yellow color chlorine, okay, will then combine with this blue color carbon. Okay, so they will actually pair up together. The two unpaired electrons will pair up together, right? The Cl dot and the carbon dot, they will join up, pair up to form a bond. Okay, but it's just that we normally don't go and represent the dots here. Okay, it's not necessary to show this. Okay, it's not necessary. So you just have to show this. Okay, and then of course the other chlorine, which I'll represent using green, when the Cl bond breaks, the other chlorine will become a chlorine radical. So you notice that this, what we mean by a chain reaction is that because in the propagation step, the end product of propagation must contain a free radical, which is this one. Okay, why is it important? Why is it important that you generate a free radical, okay, in the propagation? It's simply because you must continue the reaction. So the reaction doesn't just stop here. Propagation means it goes on and on and on. So this chlorine radical, once it's formed, okay, in the second part of the propagation, will go back and react with another alkane, another ethane molecule. And the whole propagation will start again. Okay, it will continue and continue because you generate a free radical, okay, in the second part of the propagation.